The Boeing 737 MAX is a family of narrow-body commercial jet aircraft developed by Boeing as the fourth generation of the long-running 737 series, and its story is one of ambitious engineering goals, intense competition, tragic failures, global grounding, deep scrutiny, and major changes to aviation safety culture. The 737 MAX was launched in 2011 as Boeing's response to Airbus's A320neo, which offered airlines better fuel efficiency through newer, larger engines, and Boeing wanted to keep its most popular airplane competitive without designing an entirely new aircraft from scratch, which would have taken more time and money. Instead, Boeing chose to update the existing 737 design, promising airlines lower fuel consumption, longer range, reduced operating costs, and minimal pilot retraining, which was a huge selling point because airlines already flying older 737 models could transition more easily. The MAX family includes several variants, mainly the 737 MAX 7, MAX 8, MAX 9, and MAX 10, designed to serve different passenger capacities and route lengths, with the MAX 8 being the most widely ordered and delivered. The most visible change on the MAX compared to earlier 737 models is its use of larger and more efficient CFM International LEAP 1B engines, which have a much larger fan diameter than previous engines. Because the original 737 design sits low to the ground, these larger engines had to be mounted slightly higher and farther forward on the wing, which changed the aircraft's aerodynamics, especially at high angles of attack, where the nose of the aircraft could pitch up more than expected. To address this handling difference and make the MAX feel similar to earlier 737s, Boeing introduced a software system called the Maneuvering Characteristics Augmentation System, or MCAS. MCAS was designed to automatically push the nose of the aircraft down in certain flight conditions if it detected a high angle of attack, helping prevent a stall and keeping handling consistent with previous models. However, MCAS relied on input from a single angle of attack sensor at a time, and if that sensor provided faulty data, MCAS could repeatedly command the aircraft's nose downward without the pilots fully understanding what was happening. The existence and behavior of MCAS were not clearly explained to many pilots, and in some cases it was barely mentioned in training materials, because Boeing emphasized that the MAX was similar enough to earlier 737s that extensive simulator training was unnecessary. This decision would later become one of the most criticized aspects of the program. The first major disaster involving the 737 MAX occurred on 29 October 2018, when Lion Air Flight 610 crashed into the Java Sea shortly after takeoff from Jakarta, Indonesia, killing all 189 people on board. Investigators found that faulty angle of attack sensor data triggered MCAS, which repeatedly forced the nose down while the pilots struggled to counter it, unaware of the system's behavior and unable to regain control. Less than 5 months later, on 10 March 2019, Ethiopian Airlines Flight 302 crashed shortly after takeoff from Addis Ababa, Ethiopia, killing all 157 people on board. The similarities between the two crashes were striking. Both aircraft experienced erroneous sensor data, MCAS activation, repeated nose-down commands, and pilots fighting to maintain control before crashing at high speed. After the Ethiopian crash, aviation authorities around the world grounded the 737 MAX, starting with China and followed by Europe, Canada, and many others, until finally the U.S. Federal Aviation Administration, or FAA, grounded the aircraft as well. This marked one of the most significant global groundings of a commercial aircraft in history, with hundreds of planes pulled from service and thousands of flights canceled. As investigations continued, serious questions emerged about Boeing's design choices, safety culture, certification process, and relationship with regulators. It became clear that MCAS had too much authority, could activate repeatedly, relied on a single sensor, and lacked clear alerts to pilots when something was wrong. It also became evident that Boeing had downplayed MCAS during certification and pilot training to avoid triggering costly simulator requirements, and that the FAA had delegated too much oversight to Boeing engineers under a system meant to streamline certification. Public trust in Boeing was badly damaged, and the company faced intense criticism from lawmakers, regulators, pilots, engineers, and the families of crash victims. Boeing's leadership acknowledged mistakes, and the company began working on fixes to the MAX, including redesigning MCAS to use data from both angle of attack sensors, limiting how much it could move the stabilizer, preventing repeated activations, and ensuring pilots could always override it using standard procedures. Boeing also updated cockpit displays to include an angle of attack